not all graphs are lines. Some of them are like very, very complicated. How do you graph those? Well, right now we're going to assume that all the stuff that we graph right now is smooth, which means like there aren't any jagged edges or anything weird like that. Everything we graph right now is smooth. So the question now is, how do we graph something more complicated? Let's try to graph something like this. Y equals x squared minus 1. Now what about this graph? Well, this is kind of an interesting graph. First of all, we're just going to plot points and kind of connect them. So you don't know exactly what this looks like, but we can get a feel for what it looks like just by plotting points. So let's do x equals 1, sorry, let's try negative 2, x equals negative 1, x equals 0, x equals 1, and x equals 2. Okay, so this means x equals negative 2, so we put negative 2 in for x. Now, negative 2 squared, remember that when you plug stuff in for x, or when you, well, I didn't tell you this, but when you put this in for x, you want to put parentheses around all the variables. So this would be parentheses negative 2 squared. Now parentheses negative 2 squared would be 4, and then minus 1 would be 3. So this is 3 for y. So y equals 3 when x equals negative 2. When x equals negative 1, you plug it in and you get 0. Right? Because negative 1 squared is 1, minus 1 is 0. This one would be negative 1, this one would be 0, and this one would be 3. Okay, now we can start plotting points. Let's try this. Okay, negative 2, 3, again that's here, 2 left, 3 up, that's way up here. Negative 1, 0, that's right here. 1, 0, that's down here. And let's see, sorry, negative 1, 0, negative 1 is down here. 1, 0, that's over here. And 2, 3 is up here. Now you'll notice that it doesn't form a line because if you drew from here to here, it would hit like the line about here, right? So this does not form a line. What it does is form what we call a parabola. And basically, we can draw what it looks like just by kind of connecting the dots. It looks kind of like a U shape. So if you look at this, you can kind of be like, oh, well, it looks kind of like this, and like that, and like that, and like that. Right? Okay, so this is my parabola, and yeah, that's all I have to say about that. So basically what we did was we picked a bunch of x values and I gave them to you because it's easier for me to give them to you than to pick random ones. But generally you want to pick negative 2, negative 1, 0, 1, and 2 in general to just get kind of a feel for what the curve looks like. Hopefully it'll be good for those numbers. In other words, like, for example, if this whole thing were moved to the right, then you end up with like a little line way up here, way up there. And you wouldn't be able to get a good graph out of it because you wouldn't see the curvy part here. So like, I mean, the graph could do anything. It could like curve back down or do like lots of crazy stuff, but I'm just going to tell you this is the important part, and like that's all you need to graph to get a feel for the shape. So kind of helping you out here so that we don't have to do a lot of stuff that you do in Algebra 2. Alright, so basically you have this curve. Now, the next step is what we call slope. So, slope has to do with the steepness between 2 points. Let's say we have a point here and a point here. And let's say we have a point here and a point here. Now what I'm going to do is I'm going to put a point dash here. So like these are all, this is 1, this is okay. So what you got to do is first figure out the coordinates of the 2 points. So the coordinates of the 2 points aren't that bad. The coordinate of this point is 1, 2. So let's put that here. The coordinate of this point is 0, 1. Let's put that there. The coordinate of this point is 0, 0. Let's put that there. And the coordinate of this point is 1, 0. Okay. The slope is defined very, very simply as y2 minus y1 over x2 minus x1. And the symbol for slope, or the variable for slope, is m. So y2 and y1. So let's find the slope between this point and this point. Now, you might think it might matter which one is y2 and which one's y1, but it actually doesn't matter. This could be y1, this could be y2, this could be y1, this could be y2. So we're just going to pick this one to be y2 because it's bigger than this one, and just, I like, putting the bigger number first for y2, so that's me. But the problem is that if this is y2, then this has to be x2, and if this is y1, then this has to be x1. So kind of complicated, but not too bad. You just subtract and then divide. Subtract two things and then divide them. So it's not too bad. y2 minus y1 is 1. x2 minus x1 is 1, so the slope is 1. Now this one, 0, 0, and 1, 0, what's the slope between those two? That would be, let's go this way, y2 minus y1, which is 0 minus 0, which is 0. And then x2 minus x1, which is 1 minus 0, which is 1. So that's equal to 0. Now, the steeper the slope, the more absolute value the slope has. So like, for example, this is kind of steep. This is not steep at all. Not steep at all is a 0 slope. Kind of steep is a 1 slope. From here to here is a 2 slope, as you can do by the calculations. 2 minus 0 divided by 1 minus 0, which is 2. So this slope is 2, this slope is 1, this slope is 0. Alright? So that's a basic rundown of slope. Let's have you calculate the slope between this point and this point. Or sorry, this point and this point. Between 0, 1 and 1, 0. Alright. So I'll let you have a second to do that. Hopefully you can do it in your head. So this would be 0 minus 1, or 1 minus 0, divided by 0 minus 1, which is negative 1. Alright? So the slope between the two start points is negative 1. It doesn't matter which order you do them in. You can do the other order too. 0 minus 1 is negative 1, divided by 1 minus 0, which is 1. So, make sense? Yes? Okay. Alright. So, what you gotta do is, once you have slope, you can talk about the tangent. And the tangent is a line that kind of like approximates the graph.